In this simulation, we will explain the reaction between a metal and an acid. So how does a metal react with an acid? First of all, we should examine the reactivity series of metals. So this figure shows the reactivity series of metals and hydrogen, even though hydrogen is a nonmetal. Remember that as we move up, the reactivity increases. So potassium is the most reactive metal in this list, and platinum is the least reactive one. Notice the position of hydrogen in this series. For a reaction between a metal and an acid, which means that we have H+ ions to take place, the metal must be more reactive than hydrogen. So any metal above hydrogen, so these are the metals above hydrogen, can react with an acid. However, these metals below hydrogen will not react with the acid. Let's examine the reaction between magnesium, Mg, and dilute sulfuric acid. So this is the reaction between magnesium and sulfuric acid. Hydrogen gas is produced and a salt. So actually what's happening is that magnesium, which is more reactive than hydrogen, is replacing the hydrogen ions from the solution. A salt is produced and hydrogen gas. Magnesium has a stronger tendency to form positive ions than hydrogen has, and this is because magnesium is more reactive than hydrogen. The equation of the reaction between magnesium and sulfuric acid is Mg solid, so magnesium solid, will react with sulfuric acid H2SO4, which is aqueous, to produce MgSO4, magnesium sulfate, and this is a salt, and hydrogen gas. So this is the equation showing the reaction between magnesium and sulfuric acid. Let's now examine the net ionic equation. This is the net ionic equation. Again, magnesium solid will react with 2H+. So these are the ions present in the acid. 2H+, which is aqueous, will produce Mg2+, aqueous, and H2. Notice that the sulfate ions SO4 2- do not appear in the net ionic equation because they are unchanged from reactants to products, and this means that sulfate ions are spectator ions. So actually, they don't play any role in this reaction. They are spectator ions. To understand more what's happening, let's divide this equation into two half equations. First of all, let's examine how magnesium is reacting. So magnesium solid will produce Mg2+ and it will lose 2 electrons. So magnesium will lose 2 electrons from its outer shell. On the other hand, these 2 electrons will be transferred to the protons or the H+ ions in the acid solution. They will gain these 2 electrons to become 2 atoms, which will be joined together with a covalent bond. So there's a share of 1 pair of electrons between these 2 hydrogen atoms, and thus hydrogen gas, H2 gas, is produced. This half equation is oxidation. So magnesium is oxidized because it lost 2 electrons. On the other hand, this is reduction half equation because H+ ions gained 2 electrons. Remember, oil, rig, oxidation is loss of electrons and reduction is gain of electrons. So the reaction between a metal and an acid is a redox reaction. So we have oxidation and reduction. So magnesium atoms have lost electrons, so magnesium atoms have been oxidized, whereas hydrogen ions have gained electrons, so hydrogen ions have been reduced. So the reaction of a metal with an acid is always a redox reaction because the metal atoms always donate electrons to the hydrogen ions, displacing hydrogen as a gas and leaving the metal ions in the solution.